400 years ago, the brilliant minds of Europe embarked on a quest to revolutionize the world's naval navigation systems, each driven by an insatiable thirst for revolution. And then there was Johannes Kepler, a true visionary who proposed the grand idea of exploring the galaxy with sails. In those days, it seemed more like a wild, unfathomable notion, a whisper of madness dancing on the fringes of possibility. Yet here we are, 4 centuries later, on the precipice of unraveling the immense potential of this extraordinary technology, with a promise to facilitate our voyage to the awe-inspiring realm of interstellar wonders. Join us as we reveal the inner workings of the solar sail technology and how we can use them to travel through solar systems. Since our first inception into space in the late 1950s, our celestial odysseys have grown swifter and more proficient, setting new benchmarks with each cosmic sojourn. For a fact, some experts believe that we might have outdone ourselves with everything we've achieved in space, and they're certainly not far from the truth. However, there are some significant limitations that we're yet to overcome, one of them being the cosmic speed limit and another being the fuel efficiency of our spacecraft. Cosmic scientists have struggled with these limitations for decades without much success, but they finally realized that the solution to both problems might be the complex sail technology proposed by German astronomer Johannes Kepler hundreds of years ago. After watching comet tails being whipped around by violent solar breezes, Kepler figured that this wind could be used to propel spacecraft as well. And as a knowledgeable scholar, he had a fair idea about how the same technique worked in sea travel where winds were used to move ships. Unfortunately, his idea had some flaws and was eventually disproved, but scientists have recently discovered that the force generated by sunlight is sufficient enough to propel an object through space, and that's now the solar sail idea came to be. Basically, solar sailing is an unconventional way of propelling a spacecraft or object through space. For a spacecraft to be propelled by solar energy, it must have large reflective sails that will capture and process the momentum of light from the sun to steer the spacecraft forward. A prime example of this technology is the LightSail 2 mission, which we'll talk about extensively later in this video. But first, let's discuss how solar sails work. Like normal vehicles that we drive around, spacecraft are powered by combustible fuel. The momentum of the fuel going a certain way helps to push the spacecraft in the other way. More like when you're holding a water hose. At high pressure, the force of the water gushing in one direction pushes you in the other direction. Currently, there are a few different types of fuel that a space rocket can use, but they are all stored in an onboard fuel tank, which means like the car in your garage, a spacecraft can also run out of fuel. For relatively short trips like when astronauts travel to the International Space Station, ISS, this really isn't much of a big deal because scientists tend to stock up enough fuel. However, for extensive trips to places like the moon and beyond, it becomes a big problem, especially because the more fuel you carry on board, the less cargo you'd be able to carry. And unlike the situation on Earth, there are no gas stations in space where astronauts can just drop by to fill up their tank. As you can imagine, if they ever get stranded in space without fuel, the chances of survival would be incredibly slim. And that's where solar sail really shows its worth. Unlike the technology that powers conventional spacecraft, a solar sail isn't propelled by rocket fuel. Instead, it is tossed around space by a free supply of energy provided by the pressure of a light. As you know, light is made up of tiny particles called photons. They don't have any mass, but as they travel through space, they are able to gather momentum. When photons hit the bright mirror-like surface of a solar sail, they reflect off it like a mirror, creating a bouncy effect. So when the photons strike the sail, they exert momentum on it in the form of electromagnetic radiation. This gives it a small push in the forward direction, and once they bounce off the sail, the photons deliver another subtle push. The force of each push is quite minimal, but since outer space works like a vacuum where there's really no opposing force, the speed of the solar sail increases fairly significantly with every push. And thankfully, our sun generates billions and billions of photons every single second all year round. So astronauts won't have to worry about running out of fuel whenever they're traveling through space, because there's an infinite supply of sunlight in that environment. Currently, astronomers estimate that solar sailcraft can be as large as football fields, and over 100 times thinner than an average sheet of paper. Aside from being lightweight, the materials used to construct solar sails must also be highly reflective and tolerant to extreme temperatures. For optimum rigidity, Scientists add inflatable booms and also tether the solar sail to the spacecraft. Some of the lightweight materials used in the construction of sailcraft nowadays include mylar or polyamide, coated along with a metallic reflective coating. For the crowdfunded LightSail 2 project, scientists used 4 triangular mylar sails and 4 cobalt alloy booms, which combined to cover an area of around 32 square meters, or about the size of an average boxing ring. Traditional spacecraft engines deliver more power compared to solar sail technology. For instance, one astronomical unit is equal to 150 million kilometers. Meanwhile, we also know that our sun has the capacity to generate up to 1.4 kilowatts, kW, of power onto each square meter of Earth. So if you divide 1.4 kilowatts by the speed of light, we'll discover that the force exerted by the sun is around 9 newtons, N, per square mile. In contrast, the maximum output of NASA's Space Shuttle main engine is approximately 1.7 million newtons of force during liftoff, and around 2 million newtons of thrust in a vacuum environment. But in the long run, the infinite and continuous supply of thrust from the sun could propel a solar sailcraft to become 5 times faster than conventional rockets. Generally, the speed of a solar sail would depend on its size and mass. For instance, a bigger sailcraft would gain more momentum and accelerate more quickly. A sailcraft's acceleration also depends on its distance from a light source and strength of the light source. In other words, the farther a solar sail travels from the sun, the lesser the amount of sunlight it will receive, and the slower it would become. Non-natural power sources like lasers could be used to propel distant solar sails, providing extra acceleration as they travel further into the depth of space. But practically, the starting speed of sailcraft is usually slow. The LightSail 2 project has a starting speed of around 0.058 ms2. But in one no, due to continuous thrust from the sun, its speed increased to around 549 kilometers per hour, which is about the average speed of a cruising jet airliner. The direction of a solar sail can be controlled in 2 ways. When the sailcraft is directly facing the sun, the photons produced by sunlight push it forward. However, a solar sail can also move in other directions by tacking like a sailboat, shifting the angle of the sail relative to the sun. Other methods of controlling the direction of a solar sail include changing the center of its mass or using tip vanes. As expected, sailcraft cannot be launched directly from the ground like conventional spacecraft. So a second spacecraft is needed to launch the solar sail into space before it is deployed. Alternatively, microwave and laser beams produced by satellites and other spacecraft can also be used to launch sailcraft. Due to the vast amount of research work required, developing a solar sail spacecraft can be quite expensive. But once we get a grip of the technology, sailcraft could become a very cheap option for traveling across space, especially because sunlight is free and unlimited. Quite a number of organizations have successfully built and launched different sizes of sailcraft. The biggest of them all is the Icaros spacecraft, developed by the Japanese Aerospace Exploration Agency, JAXA. Expectedly, the world's most prominent space agency got into the action with the development of NanoSail D spacecraft, and the Planetary Society joined in as well with the LightSail 1 spacecraft. Other prototypes like the NEA Scout mission and LightSail 2 mission are currently in works and are expected to launch in the coming years. Solar sail technology is unprecedented, and as it continues to evolve, scientists are confident that someday in the near future, we could be sailing across the solar system and even into the interstellar world on a sailcraft powered by the unlimited energy of the sun.